I got a middle. I think I'll stay with the middle.
Okay.
Okay. Kris Spickler, Fresno State University. Got to give a shout out to my Bulldogs. We made it to the dance. Come on. Number 14 seed. We didn't win. Got beat by Utah, but I had to at least throw that in. So, yeah, I'm from Sacramento, California. And if you don't know me, I worked for Trust Choice for about 20 years, introducing new products. And so going into mass timber was kind of an evolution of the next product for me. And I just want to say, you know, I share Valerie's enthusiasm is that as we were trying to switch out 2x12s with TJI joists back in commercial or even residential multi-story construction, that was a big deal. That was a big deal, you know. I mean, that was hard to do. But now we've got another product, and it's part of the mass timber family, whether it's glulam, paralam, and now cross-laminated timber. This is not just another generation of a rectangular beam, another generation of a different I-joist. This is a whole new product. This is the biggest thing that's happened, at least in the wood industry, if not the construction industry, in probably 40 years. So, yeah, I'm just as excited as everybody else about it. So, the topic that, Structurlam. Does everybody know where Structurlam is? Penticton, British Columbia. So you drive about 5 hours northeast of Seattle, boom, you're there. And that's about 500 miles from here. So I'd like to just say we're kind of all Cascadia. So we're kind of local too. Come on now, give me a little love here. Cascadia, come on. Okay, so gosh, this is great. My first slide's queued up. Oh, can I have that slide? Okay, so the topic was, back in the day when we first started this gig was, okay, Kris, we want you to talk manufacturing. Well, gosh, I'm a structural engineer, and I'm kind of out doing consulting, trying to develop these buildings. I'm not really at the plant, but okay, I'll take a go at it. Okay, so the topic was, so where's the manufacturing bottleneck? And I started to think about that and try to go backwards and try to figure it out, right? How many in this room are from the manufacturing sector? Something. Come on, I just want to get an idea. I like to do this once in a while. Gosh, that's a good representation. Okay, let's go engineers. Come on. Yeah, I see those Arab guys back there. Okay, architects. Okay, we need a few more of you. Okay, how about contractors, builders? Come on. We need a few more of you too, okay? Okay, now here's the toughest question of all. Which ones of you right now are in design or are building a mass timber structure? Raise your hand. Boomity bambity boom. Does that surprise you? I would have done that 3 years ago, and would we have had a hand up? Maybe one, but so that's pretty exciting. I congratulate all you guys for doing that. And now I'm not going to teach those that are already in the process. I'm not going to teach you anything. You already know what I'm about to say. But let the rest of them kind of fall into this, okay? So where's the bottleneck? Is it in the mass timber products? Is it in capacity? Is it in expertise to do it? Is it in the technology? Is it in 3D modeling? So where is it? Maybe we need to talk a little bit more about manufacturing design assist. And that's what I'm going to get into because that's kind of where I see the bottleneck. I look at the products and go, we've had glulam for 50 years, and I think we do a great job with that, right? And some of the new products that came out, paralam. Gosh, I was a big fan of paralam, and matter of fact, I put some in Southern California, this riding arena you're looking at here. That is a big, I can't say that word, something piece of paralam. Take a look at it. See, look at the bottom of the screen there. That's a guy standing there. So that beam's bigger than he is. That's a 96-foot span. That's a big piece of paralam. So anyways, it's not paralam. You know, we block glue paralam. So what's the next product? Okay. Cross-laminated timber. Yeah, Structurlam branded at cross-lam, so we got that at the top. But, okay, so is that a problem? You know, no, we've got lots of great products for mass timber out there with approvals, with experience that we can use. So, you know, that's not the bottleneck is the products we use. Well, let's talk about manufacturing. Maybe it's the manufacturing. Maybe we don't have enough capacity. Well, a recent survey told us at Structurlam we had the 4th largest capacity in the world. What? Are you kidding? Really? I thought you guys were swamped. Yeah, we're only up to a 3rd capacity. It's not capacity. It is not capacity. Technology. Well, maybe you don't have enough CNC machines. Maybe that's what you need. We got 3 of them. That's not the bottleneck. So where is the bottleneck? Where do we go? Well, if I start backing up like I have, I wind up in the design department. And sometimes I find a bottleneck in the design department. And that can be a problem. So why is that? Why is there a bottleneck in the... Well, I'm just going to tell you right up front. So you can't just... back in the day, the evolution of wood framing, you ordered a bunch of lifts of lumber, right? You ordered a bunch of beams. You sent them out to the site, staged them around. Then you went out there and you grabbed them with saws and this and that, and you cut it up and you put it up, right? It was pretty easy. You just needed 2 weeks to get your lift of lumber out there, right? No big deal. And then all of a sudden we got into TJI joist and we started doing some engineered lumber stuff, right? Then all of a sudden somebody says, we got to get a saw that automatically cuts these in packages. And it was hard for the wholesalers and the lumberyards to do it, but they did it. And so we went kind of to the next level with a little bit of drawing and packaging like that, right? So you get into commercial jobs, and now you got shop drawings, okay? You get a set of plans, 3 weeks, put out a shop drawing, get it approved in 2 weeks, and all of a sudden, 4 weeks later, you get products. And what's that, 9 weeks? So you can kind of see how this is stretching out. Okay, let me tell you this. You can't get mass timber products in just lifts and stacks and just put them around the yard and then go pick them up and cut them. You've got a crane on site, and you need to use it, and you need to use it fast. That stuff's got to come out prefabbed, right? All the products. Okay, so that's not new, right? But how do you get that done, right? What's the process in getting that done? So you have to start a mass timber project early in engaging a design assist to get the design correct to meet the material you're going to use. You would never take a concrete building and say, we're just going to rebuild this with today's new concrete mass timber products. Well, no, that was designed for concrete. You got to design it for wood. So you got to design it up front, and you also need to then plan your install sequence way ahead of time, so when it does get there, it goes up fast, right? Okay, so here's where we start. The 3D model, right? Okay, anybody that's been in this any amount of time is going, if you don't have an accurate model, you're in trouble. So you got to have an accurate model. Okay, great. So we wait till we're awarded, and somebody says, here's our architectural model, right? Got all the floor plates and stuff. Here's our structural model. You guys can use that. Well, that's great. We want to help, but now we're under the gun to take those 2 models, put them together, and say, we got a couple of, oops, this doesn't match that. I'm a structural engineer. I always go, structural governs, and just move on, right? But you can't do that, right? So you have to come up with a better plan to try to get those 2 merged together. And the best time to do it is while you're designing the project, not when you've got a gun to our head and say you need it in 8 or 10 weeks, right? That just doesn't happen. If it's going to happen accurately, come out to the site, prefabbed, every piece ready to go. So I got a quote here. You guys ready for this one? This was from Ralph Austin, who's here from Seagate. He said, consultant design to shop drawing approval can take time. He actually said a lot of times, said a few other words. I didn't include those. But once Structurlam is released for production, no one can put out glulam and CLT product faster. Ralph Austin, Brock Commons. So I talked to Ralph about that a little bit. And so one of his thoughts and what he's doing on this project, similar to what Valerie mentioned, was, you've got to start backwards and start putting it on the trucks to come and be lifted just in time. Start at the bottom and go and build it all the way up. So you can see the drawings here kind of show you the 3D model and some of the Nicholas Sills, one of our head of our design department, puts together the loads and then takes the actual footprint and looks at each of the pieces and find out where it goes and make sure that that fits what Ralph's trying to do out there. So when he goes to do this project, he can put up 2 floors a week. I'm not sure he can. I'm thinking 1. He says 2. We'll see where that goes. But my key point here is trying to engage earlier in the process to try to reconcile those models up front. So when it is time to go, you've got something to work with and you can go right into production. The problem isn't the robots. They can make it. They can get it out fast. The problem is trying to give them good information, right? So couple of keys here. As we get engaged and we go into a project, we try to do a few things. You probably got a longer list than this, but this is what I kind of look at. I try to resolve those conflicts in the model, bring it up to the design consultants early in the process before they're finished drawing it, and then I try to work out some simple and effective connections, right? Something that we can actually assist and help them with and install properly out in the field, don't have any issues. And then fine-tune the layout. Oh, I missed one. Apply constructability and tight tolerances. So, okay, anybody from the steel industry here? Oh, so I can talk bad about them. Concrete? Okay, somebody's got to be spies here. Okay, none of those guys. Okay, so as an industry, mass timber industry, we're using CNC machines. We're putting out this material that's going to be maybe 3/1000ths of an inch if we want. We can get it that close. What are you going to get in the way of steel? Well, probably tighter than concrete. Concrete, you just never know where that's going to be. I'm not bad-mouthing those. I'm just saying it's kind of the reality of what the products can do. So when you have these tight tolerances, you're going wood to wood. Some of the connections super fit, super tight. You want that, but you got to also have a little adjustability to be able to construct it out in the field. So we kind of think through some of those so we can build in tight tolerances and provide site adjustability. Maximize the CLT billet. We all make these billets, right? Whether 8 foot, 10 foot, 40 foot, 48 foot. And you want to be able to use the full billet. You want to get 98% billet utilization. That's what we call it. So we try to get a good footprint and edge, drop the panels in, and try to get full billet utilization. And that's part of the secret of doing that. Don't give us the floor plate when you're just ready to, we need material, here's the floor plate, figure it out. We want to help you do that up front. So that's another part of it. So I guess what I'm saying is, so how do you get from here to there? From a pretty drawing to a finished product. And this is one of the jobs that is a small job. You don't have to start with 8, 10, or 12, or 18 stories. You could do 3 or 4. You could actually do that. And these guys, Faction Projects, did this in Lakeshore up by Kelowna, and they just put together a small mass timber building, engaged us up front with a simple design, optimized the layout, used balloon columns and 2-direction spans for the panels. Oh yeah, CLT spans both directions. Use it. So here's kind of what it looks like. So we had the models to kind of work with them up front and try to come up with what connections would work best for them. And in doing that, we can actually take the timber and we can put the timber into one of our, let's see if I can do this. Okay. So we can actually run our model of the CNC machine and tell them, oh, hey, guess what? You're cutting too many holes in this. Could we manufacture it this way? We could probably cut it in half the time if we ran the machine this way. So we do a little bit of that troubleshooting up front to try to optimize the design up front and try to work the simplest connections in there so you don't have to wind up working this machine to death. But we can actually then see how many hours that this takes and how much time it's going to take to actually frame the project, and that gives us a better chance of doing a good estimate for you as well. So this is some of the upfront work that we have to do on a project to try to dial it in up front. And I mentioned some of the connections, whether it's going to be some of these hidden connections, you know, whether it's a Magant connection or whether it's a welded steel assembly for a column that tries to give us some adjustment in there in the tolerances. It's all tight. The tolerances count, and we got to be able to put it together. So what you wind up with when you're done with the project is a great 3D model. You've already test fit all the steel in the project. You've laid out the panel. We call it a perimeter deck and opening plan. You got to know the outside of the perimeter. You got to know the openings, and once you do, then you can start laying the panels in and get it efficient. Is this boring stuff? Is this boring? He's giving me 4 minutes. I'm excited. This is great stuff. So this is what the project looked like going up. There's the finished project. And so we found that we've done a number of projects, and some of them, such as a Wind Innovation and Design Center with Michael Green and Eric Karsh, turned out a beautiful project where we went side by side and worked together. As we were drawing shop drawings, they were still drawing plans. Worked together on that, along with the Earth Science Building up at UBC And even one of the projects out in Raleigh-Durham, the RDU Airport Terminal C, so we could work up front on that. I guess what I'm saying is that at the end of the day, we're just trying to provide expertise in mass timber systems in North America. And I think for you guys, the takeaway on this is don't get it all drawn, get it all to the point where you think you got it, and then go out to bid and see what happens. If you're doing mass timber, you need to engage up front, get the right information into the plan, draw the 3D model, get that excellent. If you get that excellent and you talk about staging up front, you're not going to have a bottleneck when I look you in the eye and go, it's 16 weeks, because we got to clean up your mess. It's going to take 8 weeks, and then we're going to make it. So did I drive that point home? Is that good? Okay, that was my drill down point of the day. Thank you. I'm done.